Hello, friends. Welcome to the new episode of Analytical Chemistry. This is going to be the episode 6. As you can see, here we want to start a new chapter, which its name is Aqueous Solutions and Chemical Equilibria. In the previous videos, we discussed some basic information, some basic knowledge that everybody need when they want to deal with analytical chemistry problems or processes. So I think now we are somehow ready to start one of the most important and essential chapters. Okay, from the title of this chapter, we can understand that we want to work with solutions. In analytical chemistry, we mostly work with liquid solutions, but the question is here, what comes to your mind when you hear the word solution? How many parts does a solution have? I give you some time, some seconds. Feel free to type it in the comment section. Okay, I think that's enough. So, for solutions, we usually have two main parts. The first part is going to be the solute, and the second part, as you probably said, would be solvent. I'm not going to provide any definition for these two parts because they're really basic and we don't even need their definitions. We never feel the need for their definitions. So using a really simple search, you can understand what is the difference. And I guess even without a search, you already know the concept of solute and solvent. But the next question here is that what famous solvent can you say? What famous solvent do we have around us? Your answer is probably water, and I have to say, yes, you're right. Water, or the chemical formula which says H2O, is one of the most, or let's say most plentiful solvent or most accessible solvent on Earth, and it can be easily purified and it's not toxic at all. So for our work in analytical chemistry, water can play an essential role and it can really help us in different parts. Now, let's talk a little about the characteristics and features of the solutions. So, first, we need to talk about the solutes that we usually use in analytical chemistry. Actually, most of the solutes that we will discuss in analytical chemistry are called electrolytes. But the question might form here that what is an electrolyte? Electrolyte is basically a substance, a material, that when it's added to a solvent, or specifically water, it dissolves into different ions, or it can form different ions in the solvent. Okay, now let's have a more, let's say, clear understanding by looking at these examples. For example, we can say sodium chloride, which is a solid, somehow white solid. When it gets into water, it dissolves into sodium ion and chloride. And both of them are soluble in water. You can't see them. So we can say that each mole of sodium chloride can give us 2 moles of ions, which are sodium and chloride. Okay, let's see another example. Sulfuric acid, or H2SO4 plus H2O, or water, will give us H3O plus, or hydronium ion, which makes the solution acidic, and HSO4 minus. Again, in this reaction, we can say that each mole of the sulfuric acid will give us 1 mole of hydronium and 1 mole of HSO4 minus. Okay, so these two reactions will undergo completely. H2SO4 dissolves completely into hydronium and HSO4 minus. Again, NaCl, or sodium chloride, dissolves into sodium and chloride ion completely, or 100%. But I'm going to give you another example, which is somehow different. The example would be about carbonic acid. H2CO3 plus water will give us H3O plus, or hydronium, plus hydrogen carbonate. In this one, it's slightly different. If we have 1 mole of carbonic acid in the beginning, the amount of hydronium ion that we will have would not be 1 mole. Actually, it will be less than 1 mole. And this is where the problem exists. Actually, it's not a problem. This is where we can categorize the electrolytes. Electrolytes are divided into 2 groups: strong electrolytes and weak electrolytes. Strong electrolytes dissolve completely in water or any other famous solvent. However, the weak electrolytes do not dissolve completely, or they dissolve partly. Now, to have a better understanding, I have a list for you. Let's check it out. Okay, look here. We can see that each group has some more subcategories. For example, the strong electrolytes are divided into 3 groups: inorganic acids such as nitric acid, sulfuric acid, hydrochloric acid, hydrobromic acid, and some more famous acids. Or the second group will be alkali and alkaline earth hydroxides. On the other hand, most of the salts are strong electrolytes. Salts like NaCl, or sodium chloride, such as potassium nitrate. And when I say alkaline earth hydroxides or alkali hydroxides, examples are NaOH, or sodium hydroxide, KOH, potassium hydroxide, and some more. On the other hand, we have weak electrolytes. Again, we have a group called inorganic acids, many inorganic acids, such as carbonic acid and some more. Next, we have most organic acids, or carboxylic acids. Then we have ammonia and most organic bases, halides, cyanates, thiocyanates of mercury, zinc, and cadmium. Here you might ask a question. The question says, how can we memorize, how can we keep all of these items, all of these substances in mind? Which one dissolves completely, which one dissolves partly? The answer is we don't need to. As we go through and we deal with problems and processes in analytical chemistry, We learn them by experience. Not all of them are needed to be memorized. Some of them, which play essential roles, are going to get memorized, let's say, automatically. Because we repeat them many times. We solve many examples. So even if you don't want to, you learn them by experience. And let's check something and wrap this video up. In this video, we talked about acids and bases a lot. On carbonic acid, hydrochloric acid, sulfuric acid, inorganic bases, organic bases, ammonia. You may ask, what is basically an acid, or what is a base? And I have to say that this would be the topic of our next video. So don't forget to subscribe and turn on the notifications. So as soon as we upload the video of acids and bases, you get notified. Thank you so much. Hope you had a great day and you found this video useful. If you are interested in more chemistry content, do not forget to follow us on different platforms such as Telegram, Instagram, and YouTube. This is Chem Explain.